Hello students, you're welcome to edumathhub. In this video, we're going to be breaking down the topic resistivity and galvanometer calculations for JAMB, WAEC, NECO. Okay, so let's start with resistivity. So the formula of resistivity is given by R is equals to rho L over A. R is equals to rho L over A. So this R that is here is the resistance of the material. Okay, so this resistance here is measured in ohms. Okay, that's the unit of this resistance. Then the next value that is here is rho. Okay, you pronounce it as rho, R-O-H-O. Okay, so this rho stands for resistivity. Okay, rho is resistivity. And the next thing you need to know is the L. So L is the length of the wire. The length of the wire that you want to measure the resistance. So the length is measured in meters. Okay, length measured in meters. Why this A that is here? A is the area of that material. So the A is the area and the unit is in meters squared. Okay, it will also be in centimeters squared. But if you are given the unit in meter and centimeters squared, you need to convert it to meters squared. So I'm going to give you the formula of how to convert it. The next thing to know is that resistivity has a unit. The unit of resistivity is ohm meter. Okay, ohm meter. So resistivity, the unit is ohm meter. That's the unit of resistivity. Before you can begin calculations on resistivity, you need to note something else, which is called the conductivity. So conductivity, this is the symbol for conductivity. Conductivity is equals to 1 over resistivity. Okay, conductivity is the reciprocal of resistivity. Okay, so take note of that. The unit of conductivity, this is the symbol for conductivity. The unit is 1 over ohm meter. Remember that ohm meter is the unit of resistivity. So the unit of conductivity, because it is 1 over, so it's going to be 1 over ohm meter. Or you can put it like this: unit of resistivity is equals to ohm meter, then open your brackets, put -1 here. So you can call it per ohm meter. Per ohm meter. So then the next thing is your conversion. You need to know your conversion very well. If you are given your length in centimeter and you want to take it to meter, just divide by 100. Okay. Then if you are given in millimeter, you want to take it to meter, just divide by 1000. Okay, very straightforward. If you are given the area in cm squared and you're planning to take it to meter squared, all you have to do is divide by 10 raised to the power 4, or 1, 2, 3, 4, 10,000. Divide by 10,000. And if it's in millimeter squared that you are given the area, and your intention is to take it to meter squared, all you have to do is divide by 1 million. That's 10 raised to the power 6. Okay, divide by 10 raised to the power 6. So everything is about division here. So let's take some questions that will help you in your resistivity calculations. Very, very straightforward. So let's start with the first question. So let's take the first JAMB question. So we are told that a wire 1.0 meter long with cross-sectional area 2.0 times 10 raised to the power -7 has a resistance of 0.1 ohms. That will find the conductivity. Take note, not resistivity, the conductivity. Okay, so let's bring out the values first. So you can see from this question that the length is 1 meter. So L is 1 meter. Then we are told that the area, that is A, is 2 times 10 raised to the power -7. Okay, very straightforward. And the resistance is 0.1. Okay, then all you need to do is put it in the formula of resistivity. So you need to find resistivity first before you can find conductivity. So let's do that now. So let's put into the formula. R equals to rho L over A. So this is the formula for resistance of a material. Then let's substitute the values. If you substitute the values, you're going to get R is 0.1. So 0.1 is equals to, you're looking for resistivity, then times the length. The length is 1. Okay, just write 1 here. Divided by the area is 2 times 10 raised to the power -7. Just write it here. So take note, in your JAMB, calculator is not allowed. So you need to know how to manipulate this. So it's very simple. Just cross multiply first. So rho times 1 will give you rho. Okay. So just write rho equals to, then you have everything here times everything here. Okay, so you have 0.1 times 2 times 10 to the power minus 7. And from here, you can use your standard form. Just express this guy in standard form. 0.1 is the same thing as 1 times 10 to the power minus 1 times 2 times 10 to the power minus 7. Then this 2, we multiply this 1. Okay, 2 times 1 will give you 2. That will give you 2 times. Then you have this guy here and this guy here. So you're going to use indices. So in indices, times is plus. So you just add the powers. Since the base is the same, consider the base is 10, 10, 10. Just add their powers. 10 to the power minus 1, then 10 to the power minus 7. So if you add their powers, you get 10 to the power minus 1 minus 7. So that will give you 2 times 10 to the power minus 8. So this is the resistivity. But this is not what you're told to find. You have to find the conductivity. So conductivity is 1 over resistivity. So you just find the reciprocal of this guy. That will be 1 over 2 times 10 to the power minus 8. Take note, in your JAMB, calculator is not allowed. So you still need to know how to manipulate something like this. It's very simple. So you just write it like this, 1 over 2 times 1 over 10 to the power minus 8. Separate it. So 1 over 2 is 0.5, Abi. So you write 0.5 times. Then this 10 to the power minus 8 here, take it up. If you take it up, the sign will change, but the number will be the same. Okay, just like if you have 1 over 2. If this 2 goes up here, it will be 2 to the power minus 1. The same way, the sign will just change, the power will change. So if this 10 to the power minus 8 goes up, it will become ordinary 10 to the power 8. So that will just be 10 to the power 8. But this option is also not, this answer is not in the option 2. So you need to still break it down. So that will give you 0.5 is 5 times 10 to the power minus 1. Then you have your times 10 to the power 8. So your 5 will see appear here. Use indices and add these guys. So minus 1 plus 8. Okay. That will be 10 to the power minus 1 plus 8. And that will give you 5 times 10 to the power 7. So this is the conductivity. So you can look for that in the option. 5 times 10 to the power 7. 5 times 10 to the power 7. So the answer is option B. So for this next question, you have to calculate the length of a Constantine wire of cross-sectional area 4 pi times 10 to the power minus 8 meters squared. And they give the resistivity as 1.1 times 10 to the power minus 6 ohm meter. You are required to construct a standard resistor of resistance 21 ohms. So what you're looking for in this question is the length. You can see calculate the length. So write the formula first. R is equals to rho L over A. That's the formula for resistance of a material. Now the next thing to do is to pick the parameters from the question. So you can see that R is 21 ohms. You can see it here. So here you just write 21 equals to. Resistivity here is also in the question. You can see it from here. Resistivity is 1.1 times 10 to the power minus 6. To write it here, 1.1 times 10 to the power minus 6 times the length. We don't know it, so write L. You're dividing by the area is in the question. The area is 4 pi times 10 to the power minus 8 meters squared. So write it there like that. 4 pi times 10 to the power minus 8. Now, take note, calculator is not allowed. You need to know how to manipulate this. It's very simple. The next thing is to cross multiply. Just cross multiply like this. This one is over 1. So cross multiply like this. So if you do that, you're going to have 21 times 4 pi times 10 to the power minus 8. Then this one here will be on its own. This one here will be by the side. 1.1. Okay, so for the next step, let's simplify this left hand side. Don't forget pi is 22 over 7. So you can write 21 times 4 times 22 over 7 times 10 to the power minus 8. is equals to 1.1 times 10 to the power minus 6L. So you can cut from here. 7 here 1, 7 in 21, that will give you 3. Okay, so here you have 3 times 4, 3 times 4 times 22. That's what you have here. 3 times 4 times 22. So 3 times 4 is 12, right? So I can just write 12 times 22 times 10 to the power minus 8. Then let me put what I have on the right hand side. So I'm going to divide both sides now by this one because it's L I'm looking for. So if you do that, this one will cancel out. You're going to have ordinary L here. Okay, now 1.1 divided by 22. You're going to get 20. If you do that, you get 20. So you have 12 times 20 times 10 to the power minus 8. This guy that is down here, take it upstairs. Take it to the numerator, take it up. But when you do that, the sign will change to plus. So just write times 10 to the power 6. Not minus 6, so because it is going up. This power will change sign. Then everything will be equals to L. Then from here, 12 times 20 will give you 240. So you have 240 times, then use your normal indices here, minus 8, because the base is the same, you can see 10, 10. Okay, so just add the powers, minus 8 plus 2 plus 6. That will give you 10 to the power minus 8 plus 6. So this will give you 240 times 10 to the power minus 2. So anytime you see something like times 10 to the power minus 2, it means that you are dividing that thing by 100. So if you see something like 5 times 10 to the power minus 2, it means you are doing 5 over 100. That's just the meaning. Okay, so this one means 240 over, because of this guy here, you're going to write 100 under. So if you cut this one, you will get 24 over 10. 24 over 10 is the same thing as 2.4. So that means the length is 2.4 meters. So you can see there that the answer is option B. So for the next question, we're told that a wire of resistivity 4.4 times 10 to the power minus 5 ohm centimeter has a cross-sectional area of 7.5 times 10 to the power minus 4 centimeter squared. We have to find the length, okay? And they give us the resistance as 4.0. So just take it, it's really straightforward. You can see that the unit here is centimeter and you have centimeter squared here. So you don't need to convert to meter squared, just leave it like that because they are going to cancel out. So you can see that the options are even in centimeters, not meters. So leave it like that, don't convert it. So let's pick the values out. So from the formula, you can see that R equals rho L over A. So that's the formula. Now let's pick the values out and substitute straight up into the formula. R is 4, okay, look at it here. So you write 4 here is equals to, rho is in a question, which is the resistivity. Look at it here. This is the value of rho. So you write 4.4 times 10 to the power minus 5. Okay, you're looking for the length. You don't know the length, just write L. You're dividing by the area. The area is 7.5 times 10 to the power minus 4. So put it underneath here. 7.5 so just cross multiply times is equals to 4.4 times 10 to the power minus 5 L. So just divide both sides by this one here. Do the same thing here. So this one will cancel out. You're going to have L, ordinary L on the left, on the right hand side. So just to solve this one, divide by 4. 4 here 1. 4 in 4.4. That will give you 1.1. So use the JAMB calculator on the screen. You need to press because it will be kind of difficult to divide with your hand to do 7.5 divided by 1.1. So just use the calculator on the screen to press 7.5 divided by 1.1. If you do that, you're going to get 6.818. Okay, so 1.1, 7.5 divided by 1.1, that will give you 6.818. So you're going to have 6.818 times. Now this is 10 to the power minus 5 here. Just take it up. By the time you take it up, it's going to be 10 to the power 5. The sign will not be there again. This minus will not be there. So it will be 10 to the power minus 4 times 10 to the power 5. So use indices here. Just add the powers. Minus 4 plus 5. That will give you 1 because times is plus. So you have 6.818 times 10 to the power 1, which is the same thing as 10. 10 to the power 1 is the same thing as 10. So that means we are multiplying this one by 10. We are multiplying 6.818 by 10 times 10. So the answer, just shift the points to this side. Okay, that will be 68.18 centimeter. So that's the length. So you can see it right here. So that's the answer, B. The 0.6 ohm resistor is made from a wire of length 4 meter. And the resistivity is 2.0 times 10 to the power minus 6 ohm meter. You have to find the cross-sectional area. So you're looking for area here in this question. So you can see that everything is already given to you. I know that your R is equals to rho L over A. So let's look for R in the question. Where is R? R is 0.6 ohms, so it's right there. So just write 0.6 here. 0.6 is equals to. Okay. Then the resistivity is also in the question. You can see it here. 2.0 times 10 to the power minus 6. So you just write 2.0 times 10 to the power minus 6 divided by, then the length. Let's look for the length. The length is 4 meters. So let's put 4 here times 4. And you're looking for A. So you can see it's straightforward. Just cross multiply. So you are dividing everything by 0.6. If you do your fast calculation, you see that A will be here. 0.6 will come under here. So you're just going to have 2.0 times 10 to the power minus 6 times 4. Then you are dividing by 0.6. You can use your normal standard form. 2 times 4 is 8. So you have 8 times 10 to the power minus 6. You are dividing by 0.6. 0.6 is the same thing as 6 times 10 to the power minus 1. Okay, so 8 times 10 to the power minus 6 divided by 6 times 10 to the power minus 1. So if you divide 8 over 6, you will get 2 here 4, 2 here 3. That's 4 over 3. Then this 10 to the power minus 1, take it upstairs here. If you take it upstairs, it's going to be 10 to the power 1 positive. Okay, so you're going to have 4 over 3 times, at the top here, you have 10 to the power minus 6. 10 to the power minus 6. Okay, times 10 to the power 1. Because this one is going upstairs, this one is going up, so the sign will be, the power will change to ordinary 1. So 4 over 3 is 1.33. If you divide it, then use indices here. Minus 6 plus 1, that will give you minus 5. 10 to the power minus 5. So this is the area here. So you can see that is the answer right here. So that's the basic idea behind resistivity calculations. All these other questions here can also be calculated using the same formula, R equals to rho L over A. Okay, so I hope you understand this section of the video. So let's move to the second aspect, which is galvanometer calculation. It always comes out every year in JAMB. So moving to the second aspect, which is galvanometer. So we're looking at how to convert galvanometer to ammeter and galvanometer to voltmeter. So let's take the first one. It's very, very simple. Okay, just be confident, you're going to understand it. So the first one is galvanometer to ammeter. So let's see how to convert a galvanometer to ammeter. So this is the symbol for a galvanometer. You have a circle, then you have G inside it, then you have what is called a galvanometer resistance. This is the internal resistance of the galvanometer. So the symbol is Rg. So you want to convert it to an ammeter. So this is the current coming in like this. Now to convert it to an ammeter, you need to plug a you need to plug or connect a low resistance to it in parallel like this. This is what it looks like. This resistance that you are plugging in parallel is called a shunt. Shunt, S-H-U-N-T. So the symbol is ROS. So you have two things here, RG, which is the galvanometer resistance, and ROS, which is the shunt resistance. So in the question, it says shunt resistance, shunt resistance. This is what they are talking about here. So to convert galvanometer to ammeter, connect a low resistance shunt in parallel with it. Take note of that. Okay? Then this is the current that is coming in. This is the current that you want to measure here. This is the current. So you see something like ammeter reading, ammeter reading. This is the ammeter reading here, I. Now, if you look at this current here, when this current gets to this junction here, you can see that it's going to split, because it's going to split into two parts. One will go down, one will go like this. Okay, so the one that goes like this here is called IG. IG. Not Instagram. So IG. That's what it's called, IG. Then the one that comes down here like this is called IS. You know that it's IS because this is shunt. Okay, and you know that this one is IG because this is galvanometer part, this is resistance part, shunt resistance part. So you have IS. Okay, now let me just give the formula straight up. You don't need to waste your time. Okay, because both of them, they're in parallel. Okay, they're in parallel. You can see that the current is splitting at this point here. The current is divided into two parts, so that means they're in parallel. Okay, so the formula for galvanometer to ammeter is this. So you have IS ROS is equals to IG RG. This is the formula for galvanometer to ammeter conversion. It's very, very simple. But you need to take something, take note of this IS. This IS, you can see this IS, it might not be given in the question. This is IS here. It is not the main current. It's not the ammeter reading. What you have here is ordinary I. So it is this I that split into two parts to get IG and IS. That means if you add IS and IG, you're going to get I. So just take note. Remember this formula too, that I, the ammeter reading, is equals to IG, the one going through the galvanometer, that's IG, plus the one going through the shunt resistance, IS. Once you remember these two things, forget, there's no question that you cannot solve. Once you remember this formula, IS ROS is equals to IG RG. Okay, so don't forget that. Okay, if you want to make it a bit complex, you can also do it like this. Instead of writing IS here, you can just write I minus IG. You can do it like this. Instead of IS ROS is equals to IG RG, you can just write I minus IG ROS will give you the same thing as IG RG. They are the same thing. Anyone you can remember, just apply it. So let's take some questions on galvanometer to ammeter conversion, and I'm going to break it down for you. So ROS, shunt resistance. IG is the current that is going through the galvanometer. I is the ammeter reading. So let's check out this question. I told that a milliammeter with a full scale deflection, okay, of 10 milliamperes has an internal resistance of 5 ohms. Okay, it will be converted to an ammeter with a full scale deflection of 1 amperes by connecting. Then they give you these options. They're asking you which resistance, which shunt resistance will you connect in parallel with it. This is ammeter here, so everything you're talking about should be in parallel. So obviously, anything in series, option C cannot be the answer. Anything that has series cannot be the answer. These two cannot be the answer. So the answer is either B or D. So let's work it out. So we are told that a milliammeter with a full scale deflection of 10 milliampere. So that means your IG is 10 milliampere. Okay, then your internal resistance, that's ROG. ROG is 5. So you're looking for ROS. Okay, looking for ROS. Then the current that it gives you, the major I, the full scale deflection current is 1 ampere. So I is 1 ampere. I is 1 ampere. So just put in the formula is I minus IG This is the second way of writing the formula. Then IG, RG. So let's do I minus IG. So your I that they gave to you is 1 ampere. Okay, so you do 1 minus, then your IG, which is current through the galvanometer, is 10 milliamperes. But 10 milliamperes, you cannot use it like this. You need to convert it. 10 milliamperes is, or you can say 10 times 0.001. So if you multiply this, you will get 0.01. Okay, so just bring it here. That will be 1 minus 0.01. Then you're multiplying by RS. Okay, your IG in the question is 0.01. Your RG is in the question, that is 5. Okay, RG is 5, you can see it here. That's the galvanometer resistance. So this one, 5 times this will give you 0.05. Then 1 minus 0.01, you will get 0.99 RS. So RS in the variable side just be 0.05 divided by 0.99. So this is the same thing as just multiply the top and the bottom by 100, which is 5/99. So you have to put it in decimal points, because if you look at the options are like this. So the shunt resistance is 5/99 ohms. So you have 5/99 ohms in parallel. Okay, in parallel. So this is the answer here. The answer is option B. Okay, so let's take another question on ammeter. So we're told that for number 14, an ammeter of resistance 0.1 ohms, so that's RG, has a full scale deflection of 50 milliamperes, so that's IG. Determine the resultant full scale deflection of the meter when a shunt of this value is connected across its terminals. So we're looking for I, okay, the ammeter reading. Here's the formula to use. So if you plug in the values, so IG, this is IG here, 50 milliamperes, that will be 50 times 10 to the power minus 3. Okay, we are multiplying by RG. RG is 4.1 equals to, so I need I is not known, I minus, that's what I'm looking for. Your IG again is 50 times 10 to the power minus 3. Everything will be in bracket like this. Then you're multiplying by RS. RS is 0.0111. 0.0111. So the next step is to just break this guy down. 50 times 10 to the power minus 3 means 50 times 0.001. So if you multiply that, you get 0.05 times 0.1 is equals to I minus 0.05. Then here you have 0.0111. So multiply these two, we get 0.005 equals to I minus so let's divide both sides by 0.0. So these two cancel out. If you divide 0.005 by 0.0111, you will get 0.45. Then this part will still remain like that, I minus 0.05. So I'm looking for I, just bring this one to this side. So I will be equals to 0.45 plus 0.05. If you add this, you're going to get 0.5 amperes. So this is the answer, but it might not be in the option. So if you multiply this by 1000, if you times answer by 1000, it will be 500. Then just write milliamperes here. So this is another way of writing the answer. I is equals to 500 milliamperes. Answer is 500 milliamperes. That's option C. 500 milliamperes. It's actually 0.5 amperes, but it is not in the option, so convert it to milliamperes. So we are told that a moving coil galvanometer of 300 resistance, 300 ohm resistance. So that means that's ROG, right? So ROG is 300. So ROG gives a full scale deflection for 1.0 milliampere. That's IG. 1.0 milliamperes. We have to find the resistance R of the shunt that is required to convert it into a galvanometer to measure a current of 3 amperes. So this is 3.0. So I is 3.0. Okay, so ordinary I is 3.0. So you're looking for RS, which is the shunt resistance. So this is how you're going to work it. IG RG is equals to I minus IS RS. So IG is 1 milliampere, okay, which is 0.001. So RG is 300, it's in the question. So I is 3 minus 0.001. They are multiplying by RS. So it's RS you are looking for. So if you multiply this 0.001 times 300, you will get 0.3 is equals to 3 minus 0.001 will give you 2.999 RS. So next step, divide both sides by 2.999. So you have RS on this side. So on this side, you have 0.3 divided by 2.999. So if you divide that, you will get 0.1 ohms. So you need to connect a shunt resistance of 0.1 ohms, which is option C. Okay, so that brings us to the end of galvanometer to ammeter. So let's take the last part of the video, which is galvanometer to voltmeter calculations. So you want to convert a galvanometer G to a voltmeter. You need to connect a high resistance multiplier in series with it. Okay, this is ROM. This ROM is called a multiplier. It is a resistance of very high value. So this is the galvanometer here. The resistance of the galvanometer is still ROG. Then there will be a current coming in like this, which is I. So you can see that the same current will pass through. It will not branch like the former case of galvanometer to ammeter. The same current will pass through the galvanometer and the resistor here. So both of them will have different voltages. They have different voltage because they are in series. This one will be VG. The voltage of the resistor will be V. Let me say R. Anyone you like. So just note that to convert a galvanometer to a voltmeter, you must connect a high resistance multiplier or a high resistor, a resistor that has a very high resistance in series with it, not in parallel, in series with it. The formula for galvanometer to ammeter 2 is very, very straightforward and it's very simple. The formula is just V over I minus RG is equals to ROM. Very simple formula. So V is the voltage you want to measure. You see it in the question. To measure a voltage of blah blah blah. I is a current that is passing through the resistance or the galvanometer. You know they are in series, they are in a straight line like this. So the same current will pass through them. While ROG is the resistance of the galvanometer. Then ROM is the resistance of the multiplier, which you'll be told to find, depending on the question. So remember this formula. V over I minus ROG is equals to ROM for galvanometer to voltmeter. So let's take some questions. So for this question, we are told that a galvanometer of internal resistance 50 ohms has a full scale deflection current of 5 milliamperes. Okay, what is the resistance required to convert it to a voltmeter? So this is galvanometer to voltmeter calculation. You are measuring the voltage of 10 volts. So this is V. This is ROG, which is the internal resistance of the galvanometer, and this is I. So if you write the formula for galvanometer to voltmeter, you we get something like this. V over I minus Rg is equals to Rm. I'm looking for Rm because we are told to find the resistance required to convert it to a voltmeter. Okay, so let's check it out. So what is V in this question? V is 10. It's right there, you can see it. So I'll just say 10 divided by I is 5 milliampere, 0.005 minus, then my Rg is in the question too, that is 50, minus 50 is equals to Rm. So I'm just going to look for this now. So if you divide 10 divided by 0.005, you will get 2000. So minus 50. So just subtract 50 from 2000. That will give you the value of Rm. So Rm will be equals to 1950 ohms. So check the option. You can see there, that's option B. Okay, let's take another question. Next question, you are told that the value of the series resistance required to convert the galvanometer below into a voltmeter with a full range deflection of 15 volts is dash. So this is V here, I've given you already. V is 15 volts. Okay, so V is 15. This is R, is not known. That's what you're looking for. That's Rm. The current that you're trying to measure there is 0.015. So Rg is also in the question. Is Rg, that's the internal resistance of the galvanometer, which is 5 ohms. So just put into the formula. Formula is V over I minus Rg is equals to Rm. So our V is 15, our I is 0.015 minus our Rg is 5. I'm looking for Rm. So divide this, 15 divided by 0.015, you get 1000. So I'll give you 1000 minus 5. So 1000 minus 5 will give you 995. That's the value of Rm. So Rm is 995 ohms. See, 995 ohms there. That's option C. So let's take one more question on galvanometer to voltmeter connection. What's up guys, thank you for watching up to this point. I really appreciate you. Please click the subscribe button and share this video with your friends so they too can learn something like this. Let's take the last question. So we are told that a millimeter of resistance, 5 ohms, okay, we want to convert it to a voltmeter. So that's a full scale deflection of 50 milliamperes, that is I. Okay, internal resistance is 5 ohms. So we want to measure a voltage of 50 volts. So they have given you everything already. This is Rg, this is V, and this is I. So you're looking for the resistance, Rm. Plug into the formula straight up. V over I minus Rg must give you Rm. It's Rm you're looking for. It is the multiplier resistance. So our V is 50. So 50 we divided by our I is 50 milliamperes, which is 50 times 10 to the power minus 3. That's 50 milliamperes. By subtracting Rg, Rg is 5. So Rg is 5. That will give you 5 here. And then Rm will be here. So the next step is to divide 50 by 50 times 10 to the power minus 3. If you divide that, you get 1000. So you have 1000 minus 5. That will give you Rm. So if you subtract this, you will get 995. 1000 minus 5 will give you 995 ohms. So that's the value of Rm. It's kind of similar to the one we did earlier. So the answer is option D. So let's take a revision of everything we've learned for today. So remember that your resistance is rho L over A. A is the area, L is the length, rho is the resistivity, and R is the resistance. This A can be in meter squared, that's units. Unit for length is meter. The unit for resistivity is ohm meter. Ohm meter. While the unit of resistance is ohms. You also have what is called conductivity, which is this symbol. Conductivity is the reciprocal of resistivity. The unit of conductivity is per ohm. So like this, then put -1 here. Okay, or you can write it like this, 1 over ohm meter. Okay, then with this on calculations, we'll move to conversion of galvanometer to ammeter. The formula for that one is IS RS is equals to IG RG. Just remember this formula. You'll be able to answer any question. So RS is the shunt resistance. IS is the current that is passing through that shunt resistance. IG is the current through the galvanometer. RG is the internal resistance of the galvanometer. You can also write the formula like this: I minus IG so this I here is the current you are trying to measure, the ammeter current you are trying to measure. But you already see something like full scale deflection of the galvanometer. When you see something like that, that is IG. Just take note of that. Okay. And to convert a galvanometer to an ammeter, you connect a low resistance in parallel with it, or you say you connect a shunt resistance. Then we'll move to galvanometer to voltmeter. Okay, that one, the formula is V over I minus RG is equals to RM. So V is the voltmeter, the volts you are trying to measure. I is the full scale deflection of the galvanometer, or the current that is passing through the galvanometer. Then RG is the internal resistance of the galvanometer. RM is the multiplier resistance. Don't forget that to convert a galvanometer to a voltmeter, you connect a high resistance multiplier, or a high resistor. A resistor that has a very high resistance. Connect it in series with it, in series. For ammeter, it will be in parallel. Okay, so I hope you enjoyed this video. Thank you for watching. You can try this next question that is on the screen. Post it in the option. Okay, try this question and solve it. Post it in the option. Thank you for watching this video. I really appreciate you. Take care of yourself. Goodbye.